Today we're going to do the lesson on 11.7, and 11.7 is involving events involving and, like the probability of and also conditional probability. And before we start, I want to review just a little bit. Let's see if I can spell review. The first one we had was what happens when we have a probability utilizing or. And so if I have a probability that A or B occurs, then remember we added then the probability of A plus the probability of B. So let's just give you an example. So like an example would be like if I had, what is the probability of rolling a 1 or say a 4? Okay, so again, I would look at the probability of both, of the probability of getting a 1. And in this case, since I'm rolling a dice, that means I'm going to have a total of 6 other possibilities, and so my probability of getting a 1 would be then 1 over 6, and my probability of getting a 4 would also be 1 out of 6. So I would add that together, 1 out of 6 plus 1/6, so then it would be 2/6, but we know we'd want to reduce that, it'd be 1/3. So that would be when we had the word or. We also jumped into odds. So odds changed just a little bit, and remember the probability, it's different than the probability because we had it out of the total, but now the odds had be a ratio that is set up between events occurring versus events not occurring. For instance, what is the odds of getting, let's go ahead and do that 4, rolling a 4 in a dice. So in this case, if I roll a 4, I have one chance to get a 4 out of the total 6 possibilities. And so my top number in favor of getting a 4 would be 1, because there would be one possibility. But then there would be 5 other options that you would not have. So my odds of getting a 4 in a dice would be 1/5. We could also remember as 1:5, and you could also write it as 1, 2, 5. And we also know we talked about what happened if it was against rolling a 4 in that. And so in that one would be the flip of it. So in other words, there would be 5 opportunities for you to do it against over the one that would happen. So your odds would be then 5-1 or 5:1 or 5-1. So that kind of gives you a little bit of review. And today we're going to jump into what happens when we have events that are happening together. And so in this case, if I had the same probability I had, and I had just the P of A and B. So if I had my same example I had, what is the probability of rolling a 1 and then rolling a 4? You would be able to go ahead and calculate that by taking the probabilities and multiplying them together. So in this case, let's just jump into our roulette wheel in this case. So this is a U.S. roulette wheel, has 38 numbered slots, 1 through 36, and 0 and 00. 18 are black, and 18 are red, and 2 are green. A ball can land on any slot with equal probability. What is the probability of a red occurring in 2 consecutive plays? Well, we start off again with the probability of a red is going to be then the 18 out of 38. But then what we're going to end up looking at is the second one. But I would almost take any of this, my probability of my red is 18 out of 38, and I'm going to simplify that just a little bit because I know that I can divide both of them by 2, and I would get 9 out of 19. And so if I had the probability of getting a red and a red on 2 consecutive rolls, my first roll I know is going to be that 9 out of 19. But then I'm also going to take it times it again for 9 out of 19 with my probability of getting a second red. So in this case, I would multiply those together, and I'd end up with 9 times 9 is 81, over then 19 times 19, which would be then 361. Or approximately, it would be about 0.224. And some of these you're going to have to round. Some of them they'll ask you to leave it as a fraction. And then, again, you can look at your answers on what, read the question carefully on how they want you to answer that question. Let's do another one. 2 events If two or more events are independent, you can find the probability of all of them by multiplying their probabilities. Let me show you what I mean. For instance, the probability of getting a baby girl is going to be 1/2 because you have either a boy or a girl, so there's two choices. The girl would be then 1 out of 2. Same thing with boy. So what is the probability of getting 9 girls in a row and using 1/2 as the factor 9 times? In other words, since the probability of getting of a girl is going to be 1 out of 2, the probability of getting in nine girls in a row would be then 1/2 9 times. In other words, 1/2 times 1/2 times 1/2 times 1/2. I know I'm writing this out when I would never do 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I would never write that out 1/2 and multiply them out that way. But what I would do is go ahead and use my power, because I know that 1/2 multiplied times itself 9 different times is actually 1/2 to the 9th power. And so in that case, it's going to be 1 to the 9th power. It's still going to be 9, so it's 1/2 to the 9th. And so that my answer, always go ahead and try and write this out. 2 to the 9th in your calculator, if you plug that in, will be 512. Goodness, I cannot write today. 512. So that's how you will go ahead and do multiple events. Let's jump over the page, and we're going to do a spinner this time. So again, if we're looking at the probability of using the spinner, it has equal probability for each of the colors, and then it'll land on one of the 6 regions. The pointer lands on a borderline, you're going to spin again. And so in other words, we'll never have something in the middle. And then the following possibilities. Okay, so in this case, it says, what is the probability to land on a red and then a blue? So again, your probability of red and blue will look like, we're going to start off with the probability of red, and in this case I have 2 out of a total number of 6 different spins. So 2 out of 6, which I know I'm going to change then to 1 over, I'm going to reduce that and have that be then 1/3. But then I'm going to do the probability of getting a blue. Anyway, this is going to change to 1/3. My probability of getting a blue, I only have 1 blue out of all of the colors, and so that's going to be 1 out of 6, and then I'll repeat that over here. So 1/3 times 1/6 then would be my multiplication problem, and I'll end up with 1/18. Again, you can keep this in the same and reduce later. So if, in other words, if I kept it as 2/6 times 1/6, I can start canceling, and I could cancel the 2 into the 6 and have 3 times, and I would end up with the same problem. So let's go ahead and jump to the next one. The next one says it'll land on a red and then another red. And so in this case, the probability will be red and red. So we'll start off with the probability of red. Remember, that's going to be, again, the 2/6. We can also, if you remember, that's also going to be changing to 1/3. But then the probability of getting another red would be also 2/6. I can simplify here before I multiply it, or I can change each of my fractions and reduce them. So 2/6 is the same as 1/3 times 1/3, and that would end up being then 1/9. I could also, from here, just cancel. 2 goes into 6 3 times, and then I 2 over here into 6 3 times, and then I would end up with the same answer as 1/9. A color other than red on both spins. Okay, so let's go ahead and just do probability of a not red and a not red. So we're going to start off with the probability of red, remember, was 2/6 or 1/3, which means that would also be then the opposite. If it's not red, it's going to be then 4 out of 6 would be not red. And then I'm going to have that again, so not red times not red. And then I can change this. So 4/6 is the same as 2/3 times 2/3. And so then my probability is going to be then 4 out of 9. Now, anytime you work these problems, remember probability, you're going to get a number that will fall somewhere between 0 and 1. And note it's not going to be larger than 1. So let's say that we made a mistake and we multiplied the top and we had 4, but then, we ended up being a larger number on the bottom. Or a smaller number on the bottom. Say we just said it was 3. We forgot to multiply the second thirds. Because 4 thirds is larger than 1, you know that you've got a problem, and so that would be another way you can kind of check yourself. All of these probabilities will be some number or some fraction that is less than 1. Okay, the next one, we're going to draw one card from a 52 card deck, and the card is replaced. And that's a key in this one, because when you do some other problems, we're going to do the next part, we're going to talk about what happens when it's not replaced. But this case, the card is replaced in the deck, and the deck is then shuffled, and you draw again. So find the following probabilities. If you draw a king the first time, and then a diamonds the second time. So in this case, we're going to start off with the probability of a king, and then so the probability of getting a king, there will be then, there are 4 kings in my deck out of each of the 4 suits, so 4 out of 52. And then I'm going to multiply the probability of getting a diamond, which is going to be then 13 out of 52. Now I can start reducing, or I can change each of my fractions. 4 out of 52, if you remember from our previous lessons, have been 1 out of 13. And then if I have 13 out of 52, then that's going to be then 1 out of 4. And so my final solution, I would multiply across, and so 1 times 1 is 1, and then I'd have 13, would be 52. The next time we're going to draw twice, but each time we're going to get a heart each time. Okay, but remember we are replacing it. So I'm going to say the probability of getting a heart and a heart. So my probability of getting a heart would be 13 out of 52. And then I'd have times 13 out of 52 again. And then I would want to go ahead and simplify to 1/4 times 1/4. And so in this case, it'll be then the final answer will be 1/16. Now, probabilities that of 2 events occur, but what we're going to do is we're going to like replace a card. So in other words, our probabilities for the populations are going to change after the second one. Let's take the first one. If I pick a person, so if I've won a trip to Madrid, and you can take 2 people with you. So we know we're going to have 2 people we select. The bad news is 10 of your cousins have appeared out of nowhere and are begging you to take them. And you write each cousin's name on a card, and you place those cards in a hat. And you select one name. Then you select a second name without replacing the card, because again, you're not going to be able to take that one cousin twice. If 3 of your 10 cousins speak Spanish, find the probability of selecting 2 Spanish-speaking cousins. Well, first of all, I need to look at the fact of what would my probability of getting 1 Spanish-speaking student. So in other words, I'm going to start with my probability of, let's go ahead and go speaks Spanish. I have a cousin, U-S-I-N, that speaks Spanish. And then I need to take it to the probability of of getting a second cousin that speaks E-A-K-E-S, Spanish. Okay. So in order for, when we look at the first one, we're going to take all of our 10, out of our 10 cousins, only 3 of them are going to speak Spanish. So my probability of getting the first cousin that speaks Spanish would be then 3 out of 10. But remember, I'm going to use one of those cousins then, so that means I'm going to have 1 less cousin that speaks Spanish, so that would be 2. But remember, I've also changed my population. If I've already pulled one of my cousins out, I'm not putting that, my population started at 10, now I have 9. And so in this case, I would take then 3/10, which would be my cousin that speaks Spanish, and then getting the second cousin that speaks Spanish, I'm going to have 1 less, And then I would also have one less in my population. But I'm still going to multiply because it's going to be two events that are occurring together. So to finish this out, I would definitely simplify this before I just take 3 times 2 and get 6 and then get over 90. I'm going to take 3 into 9 because 3 goes into 9 3 times, and it goes into 3 once. 2 goes into 10 5 times, and then 2 goes into 1 time. So now I have 1 times 1, which is 1, over 5 times 3, which is going to be 15. Or it would be then again about 0.67%, okay, or 0.67, not percent. Sorry, I'd have to move my percentage over. So that's how you'll do those when you have to read, when you're not replacing like the first card. All right, so the next one, 3 people are selected, randomly selected, 1 person at a time from 5 freshmen, 2 sophomores, and 4 juniors. What is the probability of the first 2 people selected are freshmen, and then the third is going to be a junior? So we can have multiple events. This one's going to be 3. So in this case, and it's also going to be, our population is going to decrease each time after we pull that out. But we first need to find out the total number of students. And so if you look and you add up, we'll have 5, 2, and 4. We should have then 11 students. So if our probability of the first 2 are freshmen, so I'm going to start off by probability of a freshman. I'm going to take it times the probability of another freshman after the one is being pulled. Let me put it in my second freshman. And then I'm going to go the probability of getting a junior. So my probability of getting a freshman would be then I have 5. So I have 5 out of 11. My probability of getting a second freshman. Now keep in mind, I've already used up one of my freshmen, so that means I have to have 1 less. But I also have 1 less in my population, so that's going to be 4 over 10. And then I'm getting a probability of getting a junior. Well, in this case, I have, and it's 4 juniors. So I'm going to use the 4 juniors. I haven't used any of them up. But now my population now has changed to 1 less. So it's going to be out of 9. And then I would go ahead and simplify this out. So I'd go ahead and take 5 goes into 10 2 times to make it a little simpler. And it looks like that's my best factor, so now I'm going to go ahead and go 4 times 4, which is going to be then 16. And then I'll have 2 times 11 times 9. And that would be then, oh, I could actually go another one. So 2 goes into 4 2 times. So let me just change that. So then I'll have 8. 4 times 2 is 8. And now I will have then just 11 times 9, which will make it easier. I don't have to simplify. And then I would have 8 over 99. The next example, we're going to eat some donuts. Who doesn't like donuts? All right, so Elizabeth bought a box of donuts to share. There were 2 dozen donuts, or 24 donuts in a box. And there are 3 jelly-filled. There are going to be 9 lemon-filled, and there are going to be 12 custard-filled. You are randomly selecting one donut, and you're going to eat it, and you're going to select another donut. Find the probabilities. So selecting 2 lemon-filled donuts in a row. So first of all, we want to find the probability of getting 2 a lemon-filled. How about if I go LF, lemon-filled, times then the probability of getting another lemon-filled. And so there are, in this case, 9 lemon-filled donuts. So I'm going to have 9 out of my 24 that I have as a possibility. And then I know that I'm going to use up one of my lemon-filled, so it's going to be 8 then left. Also my population from 24 to 23 because I'm going to eat one of those donuts. So now I can simplify. I'm going to say 8 goes into 24 3 times to make that just a little bit simpler. And then I can also take 3, and so 3 goes into 9, 1 times here, and then 3 times here. So I'm left with 3 times 1, which is 3, over then 23 would be my answer. The next one, I'm going to select a jelly fill. So my probability of getting a jelly-filled donut, and then times a custard-filled, the probability of a custard-filled. So I'm going to start with the jelly filled. So again, the jelly filled, there are 3. So I'm going to start off the probability to be 3 out of 24 would be my probability. And then I'm going to multiply it times my custard filled. Now remember, I don't have to reduce my numerator because they're not the same as they were the lemon filled that we did earlier. So the custard filled ones, there are going to be 12. So I still have 12 left in my box. And so I'm going to have 12, but my population, I've taken 1 out, has to be then 23, 1 less. And then to simplify this, I am going to go 3 goes into 24, 3 goes into 24 8 times. And so I'm really going to look at 1/8. And then I can simplify just a little bit. I can take a 2 out of both of these. So in other words, I'm going to take this down to 6 and this down to 4. I could actually, I could have done then 4. I could have done 4 in each one. Sorry, so this could be 3 and this could be a 2. So now I'm down to 1 times 3, which is 3 on the top, and I'm left with 2 times 23. And 2 times 23 is going to be 46. All right, the next step we're going to do is conditional probability. And conditional probability is an event B, assuming that the event A has already occurred, is called a conditional probability. And this probability is denoted by the P of B/A. And let me show you an example. So a letter is randomly selected from letters of the English alphabet. Find the probability of selecting a vowel given the occurrence of the letter has to precede H. Well, in this case, to write that, we are looking for the probability of a vowel such that the letter precedes H. So when I look at this, I'm going to start thinking about what my sample set is of the letters that precede H. So I'd have A, B, C, D, E, F, G, and then H. Whoops, and I'm going to stop at G. Sorry, it's going to precede G, but not, or precedes H, but not including it. But then I'm also going to select then the vowel of that. So the only vowel I have would be an A and an E. So in this case, my solution will be that I would have then 2 out of my population of 1, 2, 3, 4, 5, 6, 7. So my probability of getting a vowel such that all of the letters precede H would be 2/7. My last section on this one is going to be selecting events on a wheel. So in this case, I'm going to look at the number of discs is shown in a box, and 1 disc is selected at random. Find the following possibilities. Selecting 2, given that the blue disc is selected. So in other words, this is kind of like the probability of 2 such that we have a blue disc. And so I need to look at my total population for blue, and in this case I have 1, 2, 3, 4, 5 blues, so I know it's going to be out of 5. But then I have to find out how many events I have with 2. Well, I only have 1 ball that is 2 on it, so that means that my answer will be then 1 out of 5. Next one, I'm going to select an even number given that a green disc is selected. So again, I'm going to look at the probability that's even such that we have a green. So I'm going to start off with finding out how many of the balls or the discs are green. So I have 1, 2, 3 greens. And then on my even numbers, I have a green 1, I have a green 4, which is even, and a green 6, which is even. So that means I have 2 out of the 3 possibilities. I can also go select the probability of selecting a green disc given that the even number is selected. So this time it's going to be even. So I want to start off with finding out how many even that I have. So I'm going to start off, I have 1, 2, 3, 4 that are even. And out of those even numbers, how many of those are going to be green? So in other words, I have a 4 green and I have a 6 green. So I only have 2. Do I have the right? Oh, even. Yeah. So in this case, I'm going to go then 2 out of the 4 will be then green and even. Did I do that right? Yes. I wanted to double check and make sure I did that right. The last one, selecting the green disk such that a number selected is at least 3. So at least 3 means my population means it could be 1 or 2. It should be at least 3. So it's going to be 4 or 5 or 6, 7 or 8. That's my population. So in this case, I'm going to start selecting a green disk. So it's going to be the probability of getting a green such that it's at least 3. So in this case, if I start off with at least 3, I'm going to eliminate anything that's not. So I have 1, 2, 3, 4 as my possibility. That's a 3, by the way. My goodness. So I got a 4. And then I want to find out how many out of those 4 have that are green, and so I have in this case 1 out of 4. All right, that takes care of our lesson for today. I hope that makes sense.